Okay, we're going to look at degree as well as the parts of a polynomial, starting with this trinomial on the board, 5x squared plus 3x minus 1. Okay, that's considered a single variable polynomial or trinomial because we're only using x's in this. So the coefficients are 5, 3, and negative 1. This trinomial is in descending order because the highest power of exponent is a 2, is first on the variable. The x term is next, and then the term without 1, or appearing to not have 1, is last. Okay? The degree of the polynomial is 2 because the highest power of exponent is 2. Now we're going to do a table here in a moment, and we're going to talk about coefficients. We're going to talk about the degree of a term and the degree of a polynomial and the leading coefficient. Some students find it easier to turn their tablet to the side horizontally and use it that way to fill it out. If you want to do that, feel free. Okay. So on this table, you're going to have a given. I want you to put down the number of terms, which you may also have a label. We're going to determine the degree of the polynomial. The coefficients listed, and circle the leading coefficient. And I think that's all we're going to do with that right now. Okay, so we'll go with those for the moment. So let's take a look at this one. We have 7x to the third minus x squared plus x minus 8. Okay, so this is a 4-term polynomial. So it has 4 terms, and its label is just polynomial. So if it has 1 term, it's monomial, 2 terms binomial, 3 terms trinomial. But beyond that, we just call them polynomials, although sometimes I jokingly call them a quadnomial, but it's really just considered a polynomial. Now, to determine the degree of a polynomial, you have to determine the degree of a term. And below each of the terms, I'm going to put in a circle the degree. So the degree of this term is 3. The degree of this term is 2. The degree of this one is 1. And guess what? This one is 0. Okay? That's based on the 0 exponent rule, because any factor that has an exponent of 0 is replaced or substituted with 1. Okay? So if this had x to the 0 here, which would be in descending order, that equals 1. Well, 1 times negative 8 is just negative 8, so we don't show it. Okay? So the degree of each term is below the term itself. And to determine the degree of a polynomial, it's always the highest degree of any single term. So that's a 3 here. I'll go back to my blue pen. Okay? And you have to know the degree of a polynomial and have it in descending order according to the degree so that you can determine the leading coefficient. Well, let's list the coefficients first. So the first coefficient is 7. The next one is negative 1, then 1, then negative 8. Okay? The leading coefficient by definition is the coefficient on the term with the highest degree. So therefore that's 7. So we're going to circle 7 since it's the leading coefficient. I probably should have labeled this leading coefficient, and that's what we're circling. Okay? So let's do another example. So let's do x squared over 3 plus 2/5 x minus. Let's do 4. Okay. Now, earlier I told you that a polynomial will not have a variable in the denominator, but it can have fractions. But I brought this one up on purpose because a lot of times people look at x squared over 3 and can't quite figure out what the coefficient is. X squared over 3 can also be written as, oh, I don't know if I want to put it under here. I guess I do. Can also be written as 1/3 x squared. They mean the same thing. And if you have any questions about that, let me know. So 1/3 x squared and x squared over 3 mean the same thing. Okay, this is a 3-term polynomial. It's called a trinomial. Okay, the degree of the polynomial is the highest degree of any one term. This has a degree 2, degree 1, degree 0. So the highest is 2, so that goes here. The coefficients are 1/3, 2/5, and -4. Since 1/3 is on the term with the highest degree, it gets circled as the leading coefficient. Okay? Now, there's another degree determined for what we call multivariable polynomials. Those are ones that have x's and y's and z's or all kinds of variables in them. Okay, so we're going to look at multivariable. These were single variable. They're not very hard to figure out. Multivariable aren't very hard, but there's a couple things you have to remember. So I have something like x y squared minus 3x plus, let's say z to the 4th. Okay, so this is our given. There's 3 terms. It's called a trinomial. Okay, the degree of the polynomial now is still based on the highest degree of any single term, and you can tell from this one right here it has a degree 4, so I'm going to go ahead and do that one. This one has a degree 1, but this one right here is going to be degree 3, okay, because you just add together the exponents for the terms variables, okay? So 1 plus 2 gives us 3. Okay, so this polynomial would not be considered in descending order, and so I'm going to change that real quick. So it's going to be z to the 4th plus xy squared minus 3x. This is considered descending order. The degree is 4. Now, the degree tells us on this from the exponent, but the coefficient, even though it's here in the given at the end, is still going to be the leading coefficient. So I'm going to go ahead and write it the way it was given. So 1, -3, 1. Okay? And this one is our leading coefficient. Let's do another one that's multivariable. Just to make sure you get that. Let's see if I've got a good example here. Okay, so let's look at this one. 4xyz minus 10xy minus x squared, y squared. We'll go with that. Okay, so again, I have a 3-term polynomial called a tri. All right, now let's do the degree on each of these. This is going to have degree 3 because the exponents have degree 1 on each of them. You add them together. This one is 1 plus 1. This one's 2 plus 2. Okay, sometimes in your homework you're going to be asked to put these in descending order, and what it's referring to is the degree of each term. So I'm going to put this one in descending order properly. So it's negative x squared, y squared, then positive 4xyz, and then last negative 10xy. Okay, so the degree is 4 on this one. Okay, And back to these coefficients for -10, -1. It really doesn't matter because they're a list, but you do need to make sure and circle the correct leading coefficient, which is the coefficient in front of this term. So -1 gets circled on this one. If you have any questions, let me know.